Question 1, we've got a table representing a network showing the time taken in minutes to travel by car between 8 villages. Part A, using Prim's algorithm starting at A, find a minimum spanning tree, making sure that we list the arcs that form the tree in the order that you select them. Okay, so remember, by arcs, it doesn't just mean the individual letters. It means, like, if you're adding arc AB, you write down AB, not just B. Okay, so we are starting at A. So our first job is to completely delete row A. That's because we're starting at A. Once you've deleted a row, you always label the corresponding column. So I'm labeling that with the number 1 because it is the first column. We then look for the smallest number that is in any of the labelled columns. So the smallest number that I've got here is this number 8. This is the first arc that I'm adding, so I need to write it down underneath that I am adding arc AC. Okay, we then just kind of keep repeating that process. So I'm going to now delete row C because that's the one I've just circled one in. So completely delete the rest of that. Label the corresponding column, so C gets number 2 in it. And again, we are looking for the smallest number in any labelled column. Okay, so it doesn't have to be from the C, the one I've just labelled. It can be from any of them. The smallest number in column A or B is this number 9. So I've added that arc, which is arc AB. I then delete the rest of that row, label the corresponding column, which is the B, with a 3. Now looking for the smallest number in columns A, B or C because they're all numbered. So the smallest number I've got in there is this number 7, which corresponds with BH. Delete all of row H, label column H with the number 4, and now look for the smallest number in column A, B, C or H. The smallest number I've got there is this number 11, which links in with AF. So I then delete, label F with a number 5, and look for the smallest number in any of the labelled columns. Smallest number I've now got is it that number 12? Yep, so I've got a number 12 here in AG, so 12 AG. Delete, number, look for the smallest number in any of the labelled columns. Smallest number I've now got is in this column G. It is that 11, so that corresponds with DG. Delete, label. Now look for the smallest number. Now at this point you can see that we've actually got the smallest number is 15, and it appears in 2 places. It appears in BE, but it's also appearing in DE in that square there. Doesn't matter which ones of these you choose as long as it's definitely the smallest one. I mean, I'm going to choose the BE. So I've selected this one. Delete, label, and then I'm done. But obviously at this point here we could have chosen that DE instead in blue, which means that instead of having this BE at the end, I would have had DE. Both absolutely spot on solutions, both give minimum spanning trees. That's just a slightly different one, different arc added at the end. Okay, so going back to the question, let's just check we've done everything we need for part A. Let's check that's ticking, sorry. Yes, it is. Okay, so for part A, using Prim's algorithm, starting at A, done listing the arcs in the order we selected them. So that is part A done. Okay, part B, draw your minimum spanning tree using the vertices given in diagram 1 in the answer book and state the weight of the tree. Again, just make sure you actually do it at diagram 1, and just to emphasize part A, don't do it on this diagram here. Make sure you've definitely done it in the answer book. Okay, so we need to add on these arcs that were just selected. So I've got AC and AB, AC, AB. I've got DH and AF, BH and AF. I've got AG and DG, G and DG, those two there. And then at the end, I selected the BE, but you could have had DE as well. Drawn on my BE, it looks like that. Okay. Go back to the question, check we've got everything, draw a minimum spanning tree. Yep, we've done that. State the weight of the tree is the next bit. So we just need to add up the lengths of these arcs that I've drawn in there. Quickest way of doing that is just to add up the circled numbers from the table. So I've got 9 and 8 is 17, 28 with the 11, adding on the 15 gives me 43, adding on the 11 gives me 54, adding on the 12 gives me 66, plus 7 gives me 73. So my weight is equal to 73. You don't generally get a mark for units, but it's nice to have them on. We can see that this was talking about minutes, so this is 73 minutes. Okay, we've now got everything we need for part B, so we can take that bit off. Okay, part C asks if my minimum spanning tree is unique, justifying my answer. Now, the minimum spanning tree will be unique if you had to choose that arc every time when you were doing the algorithm on the matrix, the Prim's algorithm. Now, we can see that for our very last arc we selected, we chose BE, but we could have chosen DE as well. So that means that it's not unique because either of those is a correct solution. So part C, don't forget to label it as part C. No, it is not unique. Not unique. And remember, we need to justify our answer. So I'm just going to say, as we could have chosen DE instead of BE. So we've done that, we've justified our answer, so that is part C